Okay, here is an example that can help you with problem number 5 on this week's math review page. So, Mr. Nielsen, there's a typo there, but I'm not going to fix it. Mr. Nielsen is stacking boxes in his shed. His shed is 20 feet long and 10 feet wide. The boxes are 2 feet long and 1 foot wide. How many boxes could he place along the bottom of the shed? Okay, so this is technically a 4th grade problem. And it's giving us two measurements. It's giving us length and width. So length and width. That sounds awfully like a area problem. Okay, so length times width. That's going to get us the area of this shed. So what could be helpful is to sketch that out. And we have a 20-foot long by 10-foot wide shed. And to find the area, I'm going to do length times width, so 20 times 10, or 10 times bigger than 20, is 200. So 200 feet squared. That means there would be 200 1 foot by 1 foot squares in here. And then it tells me how big these boxes are. And the boxes are 2 feet by 1 feet. So to find the area of that would be 2 times 1, which is easy. That is 2 feet squared. That means each box would take up 2 square feet, just like I just did right there in the example. So how many boxes could I place in there? Well, if I have 200 feet, 200 square feet to use, so let me see what color I want to use this one. If I have 200 square feet, and each group of 2 feet is a box, this will tell me how many boxes. So I could subtract out 2 a bunch of times, or I can do division. I can subtract this out immediately. That's going to be 2 times 100. I'm running out of room right there, but that's going to be 100. So 100 boxes. I can place 100. These boxes are kind of tiny, I guess. Yeah, I guess they would be a ruler by 2 rulers. 100 boxes along the bottom of the shed. So we're not even stacking them. We're just covering the floor. It would take 100 boxes, and that's the answer to number 1. So I needed to find the area of the shed and then the area of the boxes, and then I could tell then, using some division here, I could figure out, so this would be the area of the shed and the area of the box there. I could now know I'd have 100 boxes along the bottom of the shed. There's a second part. I need to go buy the boxes. Boxes are sold in packs of 6, and I need 100. How many packs would Mr. Nielsen need to buy in order to have enough? Alright, so I need 100. I need 100 boxes. I could go division. Or, so this would be 100 boxes, and they are in groups of 6. Or I could go, I need this blank mini packs. They come in, each pack has 6 boxes, and I need it to equal at least 100. So I can think of it a different way, like a couple different ways. This way it'd be more guess and check, like do I need 10 packs? No, 10 packs will only get me 60. What if I go 20 packs? Well, 6 times 2 is 12. Add 0, 120. That's too big. So I know my answer is somewhere between 10 and 20. I don't think it's going to equal exactly 100, though. Alright, so let's check it the division way. Alright, so 6 times 10 is 60. Let's just do that. 6 times 10 is 60. I still need 40 more boxes. But buying 10 packs gives me 60. 6 times 6 is 36. Now that remainder, though, still means I still need 4 more boxes. So if I buy 16 boxes, I'm still going to be 4 short, so I need to bump that up to 17 packs. Not boxes, I need 17 packs of boxes. So I need to go to Home Depot and buy 17 packs. And that would give me enough. So I hope that helps you. That's very similar to the problems you're going to get. You do have some decimal numbers there, but it's not going to be that challenging if you just think of it. I think it's like 1.5 times 10 or something like that. If you think of it as, or 50, whatever, if you just think of it as 10 times bigger, that'll make it easier for you. But there, you can watch this a few times if you need to. That should be helpful, though. All right. Good luck.